Hi, this is Brian Fogarty, and this is a video for Chapter 9 of the book Quantitative Social Science Data with R, second edition. And in this video, what we're going to do is take a look at t-tests with independent samples, or difference in means. What is the technical name? Difference of means. Two-sample difference in means tests with independent samples. That's a mouthful. People just usually say t-tests. Alright, so I have a new R Markdown file open, set up. I'm going to run the library and set my working directory. Okay. Alright, so the data that we have in this book is not great for this. We're looking at t-tests here because they're a nice way to introduce the idea of hypothesis testing, because they're really, really simple. In this case, with independent t-tests, what we're looking to see is, given some measure, are two groups different, statistically significantly different, using the frequentist language. So it's really nice and simple to kind of use, but they're really set up for experimental or quasi-experimental kind of data, which we don't really have. We're kind of stretching it a little bit to use it here. It's fine. I mean, we're not, I don't think we're violating anything, but it's not ideal. Let's just say that. Usually the ideal case is you have experimental data where one group receives some treatment and the other one's a control, or there's multiple treatments and there's control and you compare them in some way. Anyway, all right, so what we're going to do is we will use the 2020 SIMD data. Okay, we're going to load in here tidyverse. Again, it yells at me because I'm using older version of R. So we're going to do SIMD, and then it's the read CSV, SIMD 2020.csv, and then we're going to specify the missing values as the asterisk star. Alright. Okay, so the first thing we're going to do is, so we're going to compare urban and rural data zones. So those are our grouping variable. We're going to compare them on percent depressed, so the percentage of psychiatric medication prescriptions, to see if there's a statistically significant difference in their means. What we'll do is we'll do a little bit of, rogue key hit, a little bit of recoding here just to make the variables look a little nicer. We're going to do rename width to lower, just so everything is lowercase. And then we'll use mutate, and we'll do percent depress. Okay, depress times 100. So that's this is just creating the percentage variable. We've done this before. And then, just to be clear, we'll do a separate line for our second one here. We could do it in the other one. But let's just be a little more specific. Okay, so we're going to do urban factor, and this is recode urban, where we have 1 equals, quote, urban, and 0 equals rural. So if you've been following the previous videos, we've done this several times. Doesn't like that, and the reason it doesn't like that is because it's not in quotes. There we go. That should work, hopefully. Doesn't throw a fit. There we go. It's now less angry than it was. Okay, so we can do t-tests using tidy models, which is an extension of tidyverse into doing modeling. It's more, tidy models, as we'll talk more about, is really designed for machine learning type of stuff, but they also have other things in there. But the thing is, the code is more involved than just using the base R code. So let's just use the base R code. again, there's reasons why you might want to use the more, I guess, complicated, if you will. I mean, the tidy models version, I have this in the chapter, requires you to be more explicit with everything you're specifying. Anyway, all right, so we're going to do this. We're going to use the function t.test. It's called t.test because the assumption is that it follows a student t distribution. But we're looking in difference and means here. And we have %depress tilde, and then urban factor, and then the data that we have, SIMD. All right, so again, we're seeing whether there's a difference in mean for %depressed based on, or difference in mean between the two groups for urban factor here. Okay, so let's highlight that. Okay, so we get this output here. Well, it's just two sample t-tests. We're looking to see, okay, so data tells us this, tells us the t-value, degrees of freedom, and then the p-value. All right. What we need to know, though, excuse me, is what is the null? So this actually, it's a little confusing because usually we talk about the null versus the alternative hypothesis, but this is giving us the alternative hypothesis. All right. And so the alternative hypothesis is that the true difference in means between group rural and group urban is not equal to 0. So what is that? What's the null of that, right? The null is that the true difference in means between group rural and group urban is equal to 0, which is saying there's no difference in the means between these two groups. So because our p-value here is less than or equal to 0.05, we reject the null, accept the alternative hypothesis, and conclude that there is a statistically significant difference between urban and rural data zones on %depress. All right, so this is known as like a non-directional t-test. We can also do directional t-tests where we specify that one, we're testing whether one is significantly larger or statistically significantly larger or smaller than the other. This will just depend on what your hypotheses are. And in the chapter, there's some write-up on that. Okay, so that's it for this video. Thanks for watching, and I'll see you next time.